observe this, astronomers have to take their telescopes to the final frontier.
3, 2, 1.
April 24th, 1990.
Liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
NASA's newest, most ambitious space telescope was launched.
1 minute, 30 seconds into the flight. 13 miles in altitude, 15 miles downrange, traveling almost 2,000 miles an hour.
Hubble was transported to near-Earth orbit, 347 miles above the planet. And it's still up there, sending back images that have changed our view of the universe. But all this so nearly never happened. After launch, Hubble's mirror was found to be faulty, a problem only solved with repairs made from the space shuttle. The inspiration and lessons learned from Hubble couldn't be clearer for engineers in Los Angeles. They're working on one of the most advanced telescopes ever, the Jame-Webb Space Telescope. Possibly the ultimate exploration machine. It will take infrared pictures to probe the biggest cosmological questions.
How do galaxies actually form? How do they form those spiral shapes? We don't know why.
Could life evolve in other places in the solar system? Could life evolve in other places in the galaxy or in the universe?
Is there other life out there? I mean, how much bigger can you get than answering that question?
The team's ambition is breathtaking. But if controversies over the $6.5 billion price tag don't derail the project, their greatest discoveries might be those they least expect.
Certainly with the Hubble Space Telescope, the things that we said, the reasons why we should do it and what we would find, what we actually found blew the doors off anything that we had imagined before. And with James-Webb Space Telescope, we're just creating a capability. We're opening a door to view the cosmos that could never be opened any other way.
This time, though, there will be no second chances if things go wrong.
All right, you guys ready? Just watch out all the edges and make sure we're deploying correctly. Yell stop if you see anything, okay?
Because once launched, the telescope and its distinctive 3,200 square foot sunshield will be completely beyond reach.
The James-Webb Space Telescope is actually been put in an orbit at what we call an L2 orbit, or Lagrange 2 orbit. And basically, this is a point in space. It's about 1 million miles away from Earth. We're talking a long way away. We can't get to this one.
The telescope and its reflective sunshield will be located at the L2 point so as to be far removed from sources of infrared light, which might blur its pictures. The sunshield should protect the telescope from any infrared energy that remains.
What you're seeing here is one layer of the sunshield. When it deploys out, it's about the size of a tennis court, but the thickness of it is only about the thickness of a human hair, which is about 1 to 2 thousandths of an inch.
The finished product will consist of 5 layers, each coated with silicon to reflect infrared energy away from the optics. Nothing like this telescope has ever been attempted. But perhaps even more remarkable is that the team behind it aren't entirely sure what it might discover.
I think what's really amazing is that you build this instrument, you invent all these new technologies, you have some of the most amazing people in the world contributing, and once you have this instrument operating and in space, you have no idea what you're going to find.
I think it's fair to say that telescopes open up the unexpected. I mean, that's the main reason we're sending this up there, is to see what we don't know is out there.
We can never predict the magnitude of discoveries we can make as we go and open up previously closed doors into the cosmos, into astronomy.
We're expecting to see the formation of stars and galaxies and first light, and we have an idea of what this might look like. There are models, but we don't really know, and that's why we have to send this up there, because if we don't, we'll never know.